We are back with section 7.2, and this is about the sampling distribution of sample means. We already saw the definition in section 7.1, and here it is again. So the sampling distribution of sample means is the distribution of the sample means for all possible samples of a given size and taken from the same population. Now in this section, we will learn how to do the computations with probabilities for the sampling distribution of the sample mean. We remember the standard score Z, which is also called the Z-score. So we will calculate that, and we will do the find the probabilities the same way we did in chapter 6. But the difference here is that the formula for finding the Z is not the same. It's a little bit different, which is given here. So recall that in chapter 6 or in chapter 3 as well, I believe, we use the formula Z is equal to X minus mu over sigma. But this time the X is replaced by X bar, which is the average. And then the sigma X bar is the sigma divided by the square root of n. So sigma is the standard deviation of the population, and so now sigma X bar is the standard deviation of the sampling distribution. So it is calculated by using this formula. And as I showed you in examples in section 7.1, the mean of the sampling distribution of sample means is the same as the mean of the population. So mu X bar is being replaced by mu here in the formula. Looking at the first example, it says, according to the Centers for Disease Control and Prevention, CDC, the mean total cholesterol level for persons 20 years of age and older in the United States from 2007 to 2010 was 197 milligram per deciliter. So what is this 197? This is the mu. This is the mean of the population, or the population mean. Now part A is saying, what is the probability that a randomly selected, oh wait a minute, be careful, this is very, very important, that a randomly selected, so one person selected from the population will have a total cholesterol level of less than 183 milligram per deciliter. So we have to find the probability. Basically we have to find the probability that the X, which is the distribution of the population, so X is less than 183. So how do we do that? This is what we have been doing in chapter 6. We'll find the Z-score, and then we will go to the standard table and figure out our answer. So let's do that. So this is what I want to find. What I have here is that mu is 197, X is 183, and sigma is 35. So we plug in the formula, Z is equal to X minus mu over sigma. So we get X, which is 183 minus 197 divided by 35. Take out a calculator, plug it in, and we get negative 0.4. Now you must show this work, plugging in, and then you can plug in your calculator and get the answer. So we now want minus 0.4 will be a little bit to the left of the center or left of the mean. So we want the probability that the value is lying over here in this area. So we want this area. So look up in the table, the probability that x is less than 183 is the same as probability that z is less than negative 0.4, and when you look up in the table you get 0.3446. So you can say that the probability that a randomly selected adult, American adult, will have a cholesterol level less than 183 is 34.46%. So in words, are randomly selected. So the words that you put here in your answer are exactly the same in the problem. The probability that a randomly selected adult has a cholesterol level less than 183 is 183 milligram per dl per deciliter. Or there is a, you can say there is a 34.46% chance that are randomly selected, so just repeat the whole statement again, that a randomly selected adult will have the cholesterol level less than 183. Okay, looking at the second part now. So this is asking, what is the probability that a randomly selected sample, see the difference from here? In the previous one we said randomly select that a randomly selected adult, and now we are saying randomly selected sample of 150 adults from the population will have a mean cholesterol level of less than 183 milligram per dl. So standard deviation the same. So our mu is same, 197 mg per dl. Now this the 183 is not x this time, it is going to be x bar, or the average. So 183 mg per dl, and then sigma is still 35 mg per dl. Okay, so this time to find the z-score, we need to use the mu formula. So it will be x bar minus mu over sigma divided by square root of n. So what is n? N here is 150, because we said 150 adults. Okay, so plug in. Whole divided by 35, whole divided by square root of 150. Now you plug in everything in your calculator and get the value. Now remember the z-score, it was mentioned earlier when we started finding the z-score, that you must calculate it up to 2 decimal places only. Do not put a decimal value of z more than 2 decimal places. Even if you got something more with more decimal places, then in the next step truncate it to 2 decimal places. For example, What is this value coming to? So take out your calculator and calculate this value. So I'm getting negative 4.898974 794, and I mean there is still digits there, but we have to cut it to 2 decimal places. So if you do that, you notice that it's become negative 4.9. And why? Because remember, we have, in order to truncate here, we have to look at the next digit, which is greater than 5. So we have to add 1 to the previous digit. Now previous digit is 9. When you add 1 to it, it becomes 10. So 0 and 1 is carried over, which gets added in 8. So it becomes 4.9. So now we are going to look at the probability, the same situation like we had before. We have the bell curve, and then we have the value negative, actually negative 4.9 will lie way down there on the left. And what do you think? We have done things like that. The probability that Z is less than negative 4.9, what do you think will it be? If you look in the table, this value is not available. This negative 4.9 is not there. The last value, I believe, was negative 3.9. So this is almost 0. So what do you understand from these two examples? If you note, what it is saying is that if we find the cholesterol level of one person, there is a good chance that their cholesterol level will be less than 183. But if we are finding the average cholesterol level of 150 people or 150, there is almost no chance that the average cholesterol level will be lower than 183, because in order for it to be lower than 83, a lot of values have to be less than 83, which is not possible. Okay, let's look at the next example. So it says elevators are required to have weight capacities posted if the weights of US men are normally distributed with a mean of 194.7 pounds and a standard deviation of 32 pounds. What is the probability that a random group of 10 men, so group of 10 men who enter an elevator will have a combined weight greater than the weight capacity of 2000 pounds that is posted in that elevator? Now note a couple of things here. First thing is that our n is 10. So if n is 10, according to the CLT, we cannot find the z-scores, right? But then we also read the first statement again. So it says, or the second sentence, if the weights of US men are normally distributed. So remember, that's what the CLT said, that we should have one of these things. Either the n should be greater than 30, or the question should say that the population has a normal distribution. So n is 10, mu is 194.7, sigma is 32.0, and x. So what is x? Is x 2000? No, it cannot be, right? So because that is the weight of 10 men. So we can, that is the weight of all, the total weight or weight of all 10 men added together. So how do we find the average weight of a man? We divide the 2000 by 10 and we get 200. So this is our X bar. Plug in the formula to find Z. So 200 minus 194.7 whole divided by 32 divided by square root of 10. So what do we get here? We get about 0.52. So again, we go back to the table, the question, and try to see what it's actually asking. So if you draw your bell curve here, 0.52 will be a little bit to the right of the mean 0. So we want to find the probability that the total weight is greater than. So we shade this area. So it means now we want to find probability that Z is greater than 0.52, which if you recall from chapter 6, how do we find that? We do 1 minus the probability C is less than 0.52, or we just go to the opposite of the Z score, which will be negative 0.52, and look. So you can look up that, or you can do 1 minus. In any case, the answer is 0.3015. So in words, how will you interpret your answer? The probability that a random group of 10 men who enter the elevator will exceed the weight capacity is approximately 30.15%. Or you can word it like there is a 30.15% chance that a random group of 10 men who enter the elevator will their weight will exceed the weight capacity of the elevator. Okay, looking at example 3. Now this was, again we read, so suppose that prices of women's athletic shoes have a mean of $75.15 and a standard deviation of $17.89. So we have that mu is $75.15 and sigma is $17.89. N is 50. And what is this 5? Now note here, 5, x bar is not 5. Because x bar should be close to the mu. Like it could be 90, it could be even 100. But 5 is too far. Or on the other side, it could go to 50 minimum. But 5 is too far away. 5 is not, and this is a common mistake which students do. They pick that number as x and plug in and get the wrong answer. So try to read the question carefully. So note here the last sentence is different from the previous two examples. So it says, what is the probability that the mean price of a random sample of 50 pairs of women's athletic shoes will differ from the, so these are the words that you have to be looking for in the exam. So underline them and you see them. So this is differ from the population mean. Okay, so by less than, there are two options here, less than or greater than or more than. Okay, so there will be two words, less, two types of examples or questions you can get that differs or differ from the population mean by less than or differ from the population mean by more than. We start the same way and only the difference between these two problems will be which area we select. But the calculation of z will be the same. So what it means is that if you know your population mean, what is a number which differs from mu by 5? So you can say mu plus 5. So if I call, let's say x1, I say is mu, well, let's take this the mu minus 5. So there will be two numbers. One will be mu minus 5. So the difference between mu and mu minus 5 is 5. And then the other one, x2, we take as mu plus 5. So on a side, let me show you what we mean with easy numbers. So let's say mu is 70. Then what are the numbers whose difference with 70 is 5? So you can say 65 and 75. And how can you find them? You subtract the 5 from the 70 and the other one, you add the 5 to the 70. So that's what we did here. And what do we get? So when I do x1, which is mu minus 5, so it gives me 70.15. And the x2, when I add 5, I get 80.15. Okay, so now I find z-score for each of them. So we can call this a z1. So z1 is equal to 70.15 minus 75.15 whole divided by sigma, which is 17.89 divided by square root of 50. And I keep it in parentheses because that's how we will plug it in our calculator. On the other hand, this will be Z2, which is equal to 80.15 minus 75.15 divided by 17.89 all divided by square root of 50. So now note here, I mean, yeah, you can go ahead and plug it in your calculator and find the z values, but let me emphasize something here. If you take the difference of the numerator, you will see that you end up getting a negative 5 on the top. And in the second one, you will get a 5 on the top. Plugging it in the calculator gives me so the first z value is going to be negative 1.98. And this one, the second one is positive 1.98. So we got the same values but with opposite signs, plus or minus. So I did this example like this with, finding 2x values and finding the z's for each of those x values, and then we go on from there and see what our area is going to be. But I will show you a quicker method, which is less writing, less computation. So what are we trying to find here? So making that diagram, bell curve, okay, it's looking like a skewed. Okay, this is better. Okay, so somewhere here we have negative 1.98 and 1.98. So which area do we want? So we want the difference to be less than 5, okay? Now think about it. Okay, let me make another curve and then show you. So if this is the mean, 75.15, so, and if this is the value, 80.15, and this is the value, 70.15. So now, if our value, our x, or any value x, because this is, can you see the difference is 5 and the difference is 5, okay? Now if we pick any value over here or here, so difference of that value from the mean, or the difference between the mean and that value, either on the left or right, if we are staying within these bounds, will that be less than 5 or more than 5? You can actually pick up a number, for example, between 70.15 and 75, 73 lies. So what about 73? If you take the difference of 73 from the mean, will it be less than 5? Yes. And you can do the same thing on the other side. You can pick a number over here and take the difference with the mean, and you will see that you get a number less than less than 5. So it means we want to find out this area. So now, how do we find this area? If you recall, so I go here and I will say, okay, we want to find this area. I'm going to erase this one. So now we find our area. So you remember how you find the area between two numbers? We have to find the from the table. We will look up. So this is what we want to find. Probability that negative 1.98 is less than z is less than 1.98. Now if I put equal to sign here, will it be change my answer? No. Remember, this is a continuous distribution. So putting equal to or not putting equal to sign doesn't change the value or the answer. And how did we find this? We will go to the 1.98, find its value from the table, and then subtract the value of negative 1.98. So let me see, where did my table go? Okay, so 1.98. Okay, come on. Okay, 1.9, and then I have to go to 8. 1.98. So I am getting 0.9761. Just check if this is correct. 0.9761 minus 0.9761. Okay, so that's what I got for 1.98. Now I'm going to look at negative 1.9. So it is giving me 0.0239. I will subtract. And this gives us the answer. So 0.9523. So now you can say that there is a 95.23% chance, or 0.95.23% probability, you can say, that a sample of 50 pairs of women's athletic shoes has a mean price that differs from the population mean by less than $5. Okay, so this is how we can find the. Now let us look at the next example, last one here, example number 4. And now I will show you that trick that I mentioned. So this is saying at a local manufacturing plant, the screws are being manufactured have a mean length of 1.625 inches. So mu is 1.625 inches with a standard deviation of 0.01 inches. If a quality control director randomly chooses a batch of 50 screws, so N is 50, what is the probability that the mean length differs from the mean of the population by more than 0.04 inches? So we already in the previous example I showed you how will we find our x1. So there are two values. Remember, every time we say, what if I ask you what are the two values that differ from let's say 20 by 3? So one will be 23 and the other will be 17. So one we can get by subtracting from the mean in that number, and the other by adding that number to them. So x1 will be equal to mu minus mu minus whatever this difference is, and x2 will be mu plus. So if you notice here, if I subtract the mu from both sides in both equations, so this will give me x1 minus mu equals negative 0.004, and this one will give you x2 minus mu equals 0.004. Actually, these will be with the bars. I think I forgot to put that in the previous example, although it doesn't matter much, but just to be consistent. Okay, So now notice here, this is the quantity, or this is the thing that comes in our formula in the numerator, because remember z is x bar minus mu over sigma divided by square root of n. So x bar minus mu. So if you notice here, my x bar minus mu, or x1 bar minus mu, gives me negative of this value, and the x2 bar minus mu is giving me positive of that value. So even without doing this stuff, so basically from these two equations, what we are getting is that the x bar minus mu is going to be plus or minus 0.004. Do you get that? So now when I calculate the z, I don't have to do this stuff. You can just write this, that differs from the means x bar minus mu equal to plus minus 0.004. And so z will be plus minus 0.004 divided by sigma, which is 0.01 whole divided by square root of 50. And plug in your calculator and you'll get plus minus. So what do we get? Plus minus 2.83. Okay, so now what are we trying to find here? Now that we go back, make our bell curve. I used to draw such nice bell curves. I don't know what has happened now. Oh, this is a nice one. Okay. So we have 2.83 somewhere here maybe, and then negative 2.83. So now it is saying more than that. So looking at the example that I showed you before, if you have let's say 60, mean is 60, and we go 5 up, so I have 65, 55, right? So now think about it. If I have a value in here, like I showed you before, if you pick a value in between these two numbers, 55 and 65, the difference of that value from the mean will be less than 5. But if you pick a value in these tails out here, the difference of those values from the mean will be more than 5. Yes, so it means we need the area in the tails. So we were looking for these areas. So the probability Z is less than negative 2.83, or Z is greater than 2.83. So remember, or or that changes to plus. So we will have now, we can write it as probability that z is less than negative 2.83 plus probability z is greater than 2.8. But these are the same things, right? Because of symmetry, these are same. So we can say this is equal to 2 times probability that z is less than negative 2.83. And then I look up. So I will have to look up just one value, the negative 2.83. And what we get is okay, what we get is 0.002. So 2 times 0.0023, which when multiplied by 2 gives me. So now we can say you can say the same sentence that there is very little chance. Actually, what is this in percentage? This will be 0.46%. So less than 0.5% even. Okay, there is okay, so there is very little chance. So about 0.5% or about 0.5% that. So what did the question say? That the mean length of a screw of a batch of screws will be more than will differ from the mean by more than 0.004 inches. So there is a very little chance, about 0.5%, that a batch of 50 screws will have a mean length that differs from the population mean by more than 0.004 inches. So this is how you do these problems. Okay, so next I will, in the next video, the 7.3. So that is the sampling distribution with or sampling distribution of sample proportions.